I'm going to start with an introduction to chemistry, and most of you have already had some chemistry before, so I'm going to move kind of quickly through this first portion. Chemistry is the study of nature and the composition of matter and the changes that matter can undergo. So when we talk about matter, we're talking about any object or material that has mass and takes up space. So matter can include a number of different things, anything that has mass and takes up space. It can include air, it can include the food we eat, our bodies, our clothing, and so forth. So chemistry is the study of matter. Matter has to have mass. Mass is a measure of the quantity of matter in an object. So it's basically how much stuff is there. The more massive an object is, the more force is required to put it into motion. So if I use the same force on a 16-pound shot in a baseball, the baseball is going to go further because the baseball has less mass than a shot does. We can classify matter based on its mass, but classifying matter based on mass really doesn't help us too much because a lot of different objects can have the same mass. We can classify properties of matter into two categories, physical and chemical properties. A physical property you can measure or observe without changing the composition. So I can measure the density of a substance without changing its identity. I can observe the color of a substance, and it's not going to change the substance's identity. Same with melting point and boiling point. Those are a few examples of physical properties, but a chemical property is a property a material exhibits as it undergoes a change in chemical composition. So as it changes forms, like for example, carbon burns, but helium doesn't burn. That's a chemical property of carbon that it does burn. Now, along with the physical and chemical properties, we have physical and chemical changes. A physical change is a process in which an object changes its appearance, but not its identity. Anytime you have a state change, like melting, boiling, condensing, freezing, subliming, those are all physical changes because it's the same substance. Another physical change would be like if you cut hair. It's still hair, it just looks different in appearance. Or if you crack an egg, still the egg, it just looks different. So those are physical changes. It's the same substance, it just looks different. Now a chemical change, we call these chemical reactions, but now we're transforming matter into completely different materials. So for example, hydrogen burns in air to form water. Well, that's going to be a chemical reaction. Hydrogen burns in air, it reacts with oxygen in the air to form water. This is a chemical reaction. And so we're going to be writing lots of chemical reactions because that's what chemistry really involves. Now, since no two substances have the same physical and chemical properties, we can distinguish substances based on the physical and chemical properties. Substances and mixtures. All matter can be classified as a substance or a mixture. A substance has a constant composition and distinct properties. There's two types of substances. The first type of substance is an element. Elements cannot be decomposed into simpler substances by chemical change. Now the elements, they're pretty easy to recognize because the elements are on the periodic table. Oxygen, nitrogen, magnesium, neon. They're on the periodic table. They cannot be decomposed into simpler substances. So they have a constant composition, these elements. There's more than 100 currently known elements, and they're represented by their chemical symbols on the periodic table. When you look at the chemical symbols, if there is just one letter, it's always capitalized. That's just by convention. If there's a second letter, like with magnesium, it's lowercase, and again, that's just by convention. Now, some of these come from the Latin names, like sodium's symbol, Na, comes from its Latin name, natrium. I don't expect you to know the Latin names, but you'll notice that some of them are weird, like sodium, iron, lead. They have kind of different symbols, and that's because they come from their Latin origin. Compounds are the second type of substance. Compounds consist of two or more elements combined in a fixed ratio. So for example, sodium chloride. The fixed ratio is 1 sodium to 1 chloride. So that fixed ratio is whole number ratios, 1 to 1, 1 to 2, 1 to 3. But compounds can be decomposed, so I can take sodium chloride and I can decompose it into its elements based on a chemical reaction. So I can actually break apart sodium chloride into the elements sodium and chloride. And the percent that you get from these compounds will always be the same. Sodium chloride is always 39.34% sodium and 60.66% chlorine by mass. So the percentages by mass will never change for these compounds. Okay, chemical elements in the periodic table. All elements in the same vertical column are known as a group or family. They share properties. So, for example, in group 1A, they have similar properties. Group 1A would be lithium, sodium, potassium, down that group. That's called the alkali metals. And again, we group them in vertical columns because they have similar properties based on their electron configurations, which we'll get to later. Group 2A is known as the alkaline earth metals. We'll skip over to group 7A. Now, group 7A is the fluorines, the chlorine, the bromine. Those are called halogens. And so know the name of that group. And then group 8A are called noble gases. They're rare gases. They are inert, and based on their electron configuration, they have a full shell of valence electrons, so they're very stable. I want you to know the names of these four groups, just 1A, 2A, 7A, 8A. I'm going to skip 3 through 6A, but just those 4A groups. As you go across a row, it's called a period. There are 7, if you look at the periodic table, there are 7 periods on the periodic table, 7 rows. And we can divide elements into 3 broad categories: metals, nonmetals, and metalloids. And on these 3 broad categories, the dividing line is the stair step. So if you look at the periodic table, I'll pull one up here. When you look at the periodic table, the stair step, it's not drawn in here, but there's your stair step. It starts between boron and aluminum. Anything to the left of the stair step is a metal. So these are all metals over here, plus the ones down here. These are metals as well. About 80% of the periodic table are metals. To the right of the stair step are your nonmetals. So here's your nonmetals over here. If it's right on the stair step, it's a metalloid. So for example, boron, that's a metalloid. Silicon's a metalloid. Arsenic, tellurium, astatine. They're metalloids. Now on the bottom, aluminum is a metal. Al, that's a metal, even though it's on the stair step. Germanium's a metalloid, and antimony's a metalloid. And then sometimes some people call polonium a metal, some call it a metalloid. So I'll call it a metal. Here are our, I'm going to circle the 7 metalloids on this periodic table. So metalloids are right on the stair step. Atoms are the smallest units of elements, and atoms of different elements can combine to form molecules, which are the smallest units of compounds. Okay, so all matter can be divided into substances, which are elements or compounds, or mixtures. Mixtures are combinations of 2 or more substances. Each substance retains its own identity, and the composition can be varied for mixtures. There are 2 types of mixtures. There are homogeneous mixtures, which are called solutions. They have a uniform composition within a given sample, but a varying composition from one sample to another. What I mean by that varying composition, I'll use milk as an example. Milk is a homogeneous mixture. But the composition can vary from one sample to another. There's different types of milk. There's skim milk. There's 1%. There's 2%. There's whole milk, and there's probably some more too. But the idea is this. Milk, when you look at it, looks like it's uniform, one phase. But the composition of milk can vary from sample to sample. Skim, 1%, 2%, whole milk, and so forth. Heterogeneous mixtures, the components separate into physically distinct regions. It looks like more than one phase. So with these heterogeneous mixtures, it looks like more than one phase. In the laboratory, we can distinguish a pure substance by measuring the temperature at which it changes from one state to another. A pure substance, like water, boils at a constant temperature. Water will boil at 100 degrees Celsius. So if you have pure water, it's going to boil at 100. However, if it's a solution, if you put salt in it, the boiling point will gradually increase as the mixture is boiled. So therefore, we can distinguish between a solution, like salt water, and a pure substance, looking at the boiling point. Okay, here's a chart of basically the four types of matter. Matter can be divided into substances and mixtures, and then we can further subdivide them into elements, compounds, hetero or homogeneous mixtures. And I want you to be able to tell the difference between the four at the bottom. Now, elements, those are easy because you know it's an element because it's on the periodic table. Compounds. Compounds are elements combined in a fixed ratio. So compounds are something like sodium chloride or barium sulfate or lithium nitrate. Those are all fixed ratios of elements combined. Now when we get to the mixture side, there's homogeneous and there's heterogeneous. I'm going to start with homogeneous. Homogeneous mixtures, I'm going to try to make this as simple as possible. Air is homogeneous, and then anything dissolved in water is also homogeneous. And what do I mean by anything dissolved in water? I mean like tea, I mean Kool-Aid, salt water. Anytime you see something dissolved in water and it looks uniform, that would be homogeneous. Okay, so that leaves most everything else as heterogeneous. Most everything else around us is heterogeneous. 99, probably 0.5% of the stuff around us is going to be heterogeneous. If it does not fit into one of the previous categories, it is heterogeneous. Rocks, wood, firewood, desk, people. I mean, 99.5% of the stuff around us would be classified as a heterogeneous mixture.